Muy buenos días a todos. Espero que estén teniendo una feliz día. Como Vicky les comentó anteriormente, estamos esperando unos minutos, por favor, que se termine de ingresar la gente. Las personas registradas, teníamos alrededor de los 180 registrados. Vamos a esperar, por favor, unos 5 minuticos, 5 o 6 minuticos, que se terminen de ingresar todo el mundo. Mientras tanto, por favor, vayan metiéndose en la página de aquí abajo, en el banner que les aparece en el Zoom. Hay un cuadrito que pone recursos. Les recomiendo que entren ahí. En la página de recursos van a tener dos tipos de recursos. Un primer recurso que es de enlace, en el cual tienen directamente lo que es el contacto para cualquier tipo de solicitud, ya sea de consulta técnica o solicitud comercial, solicitud de cotización, como también tienen una segunda sección que es documentación. En esta segunda sección de documentación tienen todo lo que son los folletos, tanto generales para que entiendan la generalidad de todo lo que es la realidad de protección de arco eléctrico Littelfuse, como también los folletos ya indicados por cada una de las series de los relés que tenemos. Bueno, sin que más que decir, por favor, cualquier consulta, pregunta, simplemente levanten la mano o simplemente, por favor, escríbanlo por la pregunta, por la parte de pregunta y respuesta, que estamos atentos, ¿vale? Good morning to everybody that speak English here. We have people from Belize, Trinidad, Tobago, and Guyana. Please, let's wait a few minutes. In the meantime, please enter in the resource page, and there you can find two type of resource. The first one is the links, and with the links you can visit Littelfuse website or YouTube web channel where there's a lot of nice videos explaining the Arc Flash capabilities. And also you have the link to connect through WhatsApp with Vicky Corsagas, and any question or quote, everything you need, Vicky will be there for you. Please, let's wait a few minutes. We are waiting for the people to join. We already have 31 people with us today. Let's wait, please, 2 more minutes, and Mark will begin the webinar. Any question or concern, please make sure to use the question and answer section that is below in the Zoom, and we will respond immediately, okay? Mark, let's wait 2 more minutes and let's begin it. It's okay?
Sure, no problem. I'll wait for you to come back and let me know when to start.
Perfect. I will. Para quienes se han conectado en los últimos minutos de habla España, de habla español, perdón, por favor vayan ingresando en la parte de abajo, en el Zoom, tienen un recuadrito, en el cual en el recuadrito ese que está colocado abajo hay una sección que se denomina recursos. Si ingresan ahí, van a tener dos tipos de recursos. Un primer recurso que son enlaces en los cuales tenemos el enlace directo a lo que es la página de Littelfuse enfocada en los relés arcoeléctricos. Luego también tenemos el enlace para lo que es nuestro canal de YouTube, en el cual hay unos excelentes videos que explican las capacidades que tienen los dispositivos del Littelfuse para la protección de arco eléctrico. Y luego tienen otro enlace que es directamente para el contacto de María Victoria Corsaca, quien es la Product Manager en ser del Littelfuse. Y cualquier consulta, inquietud técnica, cotización que requieran, ahí van a poder de una vez pedírsela a Vicky. Estamos dando solamente un minuto más. Ya tenemos a 44 personas con nosotros. Y bueno, empezaremos, ¿vale? Que tengan un feliz día y cualquier cosa, por favor, como les comento, tienen la parte de preguntas y respuestas o pueden levantar la mano y al levantar la mano les damos el acceso para que puedan hablar. Okay, Mark. I think we wait a cautious time. Let's begin. Let us do the presentation, and well, then it's your time to talk. Well, good morning, everybody. We are USA, the Latin American representative for Littelfuse. Here we have all the team, from the general manager, the product manager, the operational manager, and also we have Mark Pollock, the director of Littelfuse for all around the world. This webinar will be in English, complete in English. Mark is a Canadian, but we are here for translate for all our Spanish speakers. Anything you may help, if you need help, we are here for you. And for the English speakers, I hope that it is a really good introduction for the capabilities of Littelfuse and their Arc Flash relays. Any question, please do not hesitate and do it by the question and answer section, or just please raise your hand and we will allow you to talk. So, well, that's been said. Mark, please go ahead. You already have the permission to share your screen. Y
Okay,
para todos los que hablan español, sorry Mark, a minute, y para todos los que hablan español, nuevamente aquí les queremos dar la bienvenida. Ya tenemos alrededor de las 55 personas alrededor de todo, que vamos desde Centroamérica, Caribe y llegamos hasta Argentina. Tenemos a unos argentinos con nosotros. Esto es una presentación enfocada netamente en lo que es la mitigación de arco eléctrico con los productos de Littelfuse. Va a estar a cargo de la presentación el señor Mark Pollock, que es la persona encargada, el director a nivel mundial de ingeniería y de aplicaciones de tanto de los relés arcoeléctricos como todo el portafolio de relés. Cualquier consulta que tengan, pregunta, por favor no duden en colocarla en la sección de preguntas y respuestas o simplemente levanten la mano y les vamos a dar el permiso para que puedan conversar. ¿Vale? Y bueno, espero que sea una excelente reunión. And so, Mark, there you go. Go ahead.
Okay, thank you. So good morning, everyone. Yes, I apologize that I do have to give the presentation in English. My language skills are not what they need to be, but hopefully I can you can still follow along. And really appreciate that you've taken some time to join us, and excited to talk a little bit about arc flash mitigation. So a little bit of my background: I've been with Littelfuse quite a long time, almost 20 years now, and I am based in Canada. So we have an engineering office here in Canada where we do a lot of the design work for the protection relays. And I've worked with applying those protection relays and helping customers for all of that time. But probably the last 10 years have also spent more time with some of the codes and standards. So working with IEC, with UL, with a number of the other groups. So it gives a little bit more perspective in how these products are applied as well. And this page will be in this document here for your reference. So we work together with SER and really happy to have them represent us. So their contact information is here. For any questions you might have, please reach out to them, and they'll be happy to help you. So I want to start with one quick comment, or I guess a little bit of a cartoon. And when we talk about electrical safety, it's something that it's not just one single person, their job to worry about electrical safety. It is something that we want to make sure everybody is aware of how to work safely around electrical equipment. And so it is something that being aware of what the risks are and being aware of some of the things you can do to prevent things like arc flash or to reduce the danger in that arc flash, then it's just good to understand that and know what you can do about it. So it is something that has to be built into the corporate DNA, into the company. We should aim to do things in a safe way all the time. It's not just one person's job to keep everything safe. So today we are talking about arc flash. And I'm not going to spend a lot of time on, we'll say, the arc itself. We want to focus on the things we can do to reduce that arc. But it is good to have at least a slide or two just to talk about what is, an arc flash. So thinking of hazards or risks that we have when we're working with electricity, one of the big ones is electric shock. So that's when you're touching something that's energized, there's current that comes into the body. That is one of the hazards working around electrical equipment. Then we have arc flash. So that is a really intense release of energy that occurs when you have current flowing where it is not supposed to flow. So normally air is supposed to be a barrier, but when you have current going across that barrier and arcing, it does release a lot of energy. And then an arc blast, when an arc flash occurs, it does pressurize that piece of equipment, and it can create a blast that can throw out, metal particles and shrapnel into the air. So we are looking at the arc flash event. So as I mentioned, if you have two copper bus bars, separated with an air gap, that air is an insulator. There's not supposed to be current flowing across it. It's very, very high resistance or impedance. And so when you have an arc that forms across those bus bars, so making a path where a current is not intended to flow, it generates an intense light, and that arc also creates a tremendous amount of heat. So that heat is very, very hot. The arc itself can be, up to 20,000 degrees Celsius, and that extreme heat in that arc will really vaporize the copper. So it turns from a solid to a gas and expands in volume. As it expands in volume, it pressurizes the compartment, and then that can cause the blast of the enclosure, and then all of that heat and the toxic gas and everything can come out and affect somebody who could be standing by. So you may have seen various videos. This is just one that I like because it's in very slow motion. So this whole video clip is only talking about a few milliseconds, but you can see when you slow it down, the tremendous power that's inside that panel. So this is an arc just captured with a very, very high speed camera, almost 1,000 frames per second. And you can see the AC wave pattern of the arc in that pulsating fashion. The next slide shows an arc as well, but this one shows just how much molten copper and metal particles come out of the arc. So again, in slow motion, you can see if somebody was standing in front of that panel, all of those red hot liquid metal particles would be coming out, towards them. So, of course, there's a risk to people standing nearby, but the equipment itself can also be completely destroyed. And the building can end up with a fire, but the equipment itself can be completely destroyed, which could take many weeks or even months of time to get replacement equipment, and very costly in terms of damage. So when we look at reducing the energy of an arc flash, of course it makes sense, but there always is questions about, is it required? Where is this required or in the law? And a lot of areas are beginning to make arc reduction a part of the mandatory electrical code, and put into the actual laws. So in the US, for around 10 years, that has already been in the law. In Canada, that was added this year, actually, in 2024. And Brazil has also had a requirement in NR10 for quite a few years to take measures towards arc flash prevention and mitigation. So it is something that is understood to be a risk, and it is growing the number of areas where it's actually put into the law that you have to do something to reduce the energy. So if we want to look at how should we reduce that energy, what can we do about it? There's a lot of things that can be done, and there's a few interesting documents. I'm not going to spend a lot of time on these standards or these documents here, but I just want to highlight them in case you're interested to look. So one of the things that gets talked about a lot is this hierarchy of risk controls. So if we look at ways we can help reduce the energy, if we categorize them in this pyramid, we want to move to the top. So these ones are the most effective. So if we just look at how can we reduce the risk, of course, the most effective thing to do is just to erase or eliminate the hazard altogether. Now, if you go to the bottom and look, well, we can give the worker, the appropriate gloves and suit. That's important, but that's not going to stop the arc flash from happening. And so there's different things we can do. And as we move up to this pyramid, it gets more and more effective. And so these documents talk about strategies and things you can do for safety management systems. And probably, if you're going to remember one standard to help you look at electrical safety, NFPA 70E is probably one of the best. So there's also a CSA standard that is quite close. They work together for Canada, but these two documents talk about electrical safety in the workplace. And so these are really good references if you're looking for how to develop a safe way to do things. They have example worksheets of how to develop a safety program and how to have job checklists, in order to maintain safety. So these are good references if you're interested. So if we want to look at some of the specific things to do around arc energy reduction, of course, we have PPE, so personal protective equipment. And this is absolutely critical. So it's very important to have the electrical workers having PPE that is appropriate in order to do that job. But it's really the last line of defense. We don't want to rely on this equipment, the gloves and the face shield and the suit. We don't want to rely on that as the only defense. We want to reduce the arc energy to begin with. So the suit itself, although it might protect you in the case there is an arc flash, we don't want the full arc flash energy. We want to reduce that energy. Another thing that is talked about a lot is arc resistant switchgear. So this is equipment that is designed that if there is an arc flash, it is contained inside the equipment. It's built strong enough so the doors do not break open, and all the energy is redirected out. And usually there are flaps on the top, or there might be a plenum that goes outside the building and directs the energy out. So this does a really good job of making sure somebody who is standing here may not get hit with the arc flash. Now, this equipment, because it's built to be so much stronger, it is quite expensive. So sometimes it's 2 or 3 times as much money as the regular switchgear. And although it might prevent somebody standing here from getting severely injured, it does not reduce the energy. So the equipment inside is still going to be heavily, heavily damaged. And so there could be a high cost to replace it. And if somebody has the door open, doing something inside, then it really is not going to do its job because the door is open. It can't block the energy inside. So arc flash or arc resistant switchgear, it certainly can be good, but just have to understand how it does not reduce the energy and so does not reduce the damage that could occur inside. Another thing you may see is on different types of circuit breakers, they have what is called a maintenance mode switch. And so this is a manual switch where you can put the breaker into what's called maintenance mode. And really, that turns the overcurrent into a very fast-acting, instantaneous trip. So then, anytime there's a blip of current that goes above the rating, the breaker will react very, very quickly. So it does reduce the arc energy. But the issue here is that it is subject to human error. So what if somebody forgets to turn the switch to maintenance mode, and then they open the door, they do their work, the energy has not been reduced? The other thing that can happen is they could leave it on accidentally. And the problem there is once that's turned on, it's very, very sensitive. And if you have a motor inrush or some other event that normally is considered okay, just a small increase in current temporarily, the breaker could then trip off. And so it's something that is subject to that human error. And it also means because it only is activated when you turn it on with the switch, it only works during that time you're doing the maintenance. So some other arc flash events occur somewhat, I won't say randomly, but if there's dust buildup or some other problem in the equipment that causes the flashover, not somebody doing maintenance and touching something or hitting something with a wrench. If it's just an event that occurs because of other environmental effects or mechanical damage, then those arcs cannot be reduced because nobody has switched the maintenance mode on. So we really feel that arc flash relays are an excellent way to provide arc energy reduction. So we'll talk more about that here. And a few of the reasons is that it's always on. So these relays, once they are installed and working, they're always watching for the arc. They don't rely on somebody to turn them on or remember to turn them off. They're just always there in the background. So it takes away that element of human error that can get in the way. The system is also quite easy to install, both for new equipment and for retrofit. So if you have existing cabinets, these arc flash relays are quite easy to put into an existing system, which is also quite important. Another item is that these protection relays, I'll talk about the specifics in a moment, but they are designed with some very interesting self-check functions. Because it's a safety relay, we really want to make sure that it's doing its job, and because we're relying on it, we're trusting it to be there when there is an arc. So there is several layers of self-check to make sure the system is operating as you expect. And of course, they are one of the ways that you can achieve a very strong reduction in the arc flash energy. So when we have an arc flash, the amount of energy that comes out, it rises very, very quickly. So even within a couple hundred milliseconds, so in the amount of time it takes to blink your eye, there is already a huge blast of energy that's coming out. So the way that we can reduce that energy is by shutting down the system as fast as possible. So these arc flash relays are able to see the arc and provide a tripping signal to the circuit breaker in less than 1 millisecond. So that is very, very fast. Now, the breaker has an operating time to clear, but at least on the relaying side, we are giving that signal extremely fast as possible. And by clearing, by opening the circuit and clearing in that type of 50, 60 millisecond time frame compared to 100 or 200 or longer milliseconds, in many cases, the arc energy is reduced, by 50, 80, 85%. So a huge reduction in the amount of energy. So to talk a little bit about the Littelfuse arc flash relays that we have, there's 4 different models, but all of them operate on the very similar principle of looking for the light from an arc flash and reacting very quickly and connecting that to a circuit breaker or an interrupting device that can clear the circuit. So I'll talk a little bit more about each of them, but first, because they all use the same light sensor technology, I want to talk a little bit about that. So these light sensors are installed inside the cabinets, and they will look for the light that comes from the arc that starts to burn. And one sensor has a pretty good window. You don't have to get super close. You don't have to be 2 centimeters away from the arc. These sensors can see, 2 or 2.5 meter distance for a relatively small arc. So if you think about one piece of equipment, you could have a light sensor in in the ceiling on the top of the enclosure, and it could see an arc all the way down to the bottom. So this is a single point sensor that you install in one location, and it can see, in this hemisphere, like I said, about 2 to 2.5 meters. So this is a copper cable that connects it back to the relay, and this is really designed to be extremely easy to use. So that was one of the guiding principles on the product design. So this is the easiest and fastest product to use on the market, when you're retrofitting, and that can be important because downtime, may not last very long, and you may need to put these in to existing equipment, without taking 2 or 3 days. You want to do this project in a couple hours. So these sensors are plug and play. And what I mean is you plug in the sensor into the relay will recognize it, and from that point forward, we'll expect it to be there. So if the sensor itself has any problem, or the cable becomes cut, then the relay would give an alarm. So you do not even need to program the relay to tell it how many sensors. It just automatically recognizes them once you plug them in. So a single point sensor is very convenient to mount all over the equipment, exactly where you want to see the light, such as the terminals on a transformer or things like that. But if you have large equipment, you may want a fiber sensor. So these are, I've sometimes heard these called, a fiber rope sensor. We just usually call them our fiber sensors. But this is a relatively long fiber that can be either 8 or 18 meters in length. And it is able to see an arc anywhere down that fiber. And again, the radius here would be about 2 meters. So it can see about a similar distance. And when an arc occurs and that light comes into the fiber, this is special fiber that's designed to bring light in and trap it. So it will follow down the fiber and be measured on the receiver side. And then the information given to the relay. Now you can see in the picture, we have the fiber sensor part connected to a transmitter and receiver. So you put the fiber where you'd like to measure light, and then the copper wiring goes back to the relay. Now this, again, makes it easy to install because the copper you can put through all your regular cable channels, go around tight corners, you can bend it if you need. In some cases, if you have large equipment and it's split in sections, you could even cut the copper cabling and have it connect with terminals. It makes it very flexible. So this cabling does make it very easy to use. The fiber itself also has a very unique self-check that I'll talk about in a moment to make sure that the fiber is not cut or damaged as well. And again, because we want this to be extremely easy to use, some fibers on the market, they give you just a length of fiber, and the customer has to cut and polish the end and put on the termination. But that is something that could end up with problems or reliability problems if it's not done correctly. So we provide the fiber already terminated, and all you have to do is plug it into the receiver and the transmitter and tighten the plastic nut, and then it's ready to go. So we want to make sure that it's fast and easy, but at the same time that it's reliable and there's no chance for problems to occur in the field. Now I mentioned the self-check. So both of these sensors have an interesting self-check. And this single point sensor here on the left, there is a red LED inside the body. And when you plug it into the relay, that LED will flash. And that light from the LED is actually picked up by the sensor. And then the sensor transmits that to the relay and confirms we have a correct test signal. So that's verifying the circuit, and that's verifying the cable as well. So if there's any cut in the cable, the relay would know instantly that this is not working. Now for the fiber, it's a little different, but we inject a small light down the fiber that is measured at the receiver, and again, we confirm that's a correct test signal. So we're verifying the fiber itself. We're also verifying the electronics in these transmitter and receiver boxes. So this is an active self-check to make sure that these sensors are operating as you expect. So that's the first part of the self-check system. The second is that the 8800, this one model does have the ability to bring in current as well. So some customers have expressed some concern. What if we have somebody with a, we commonly have people with lights, flashlights looking in the equipment, and we're worried about that triggering the arc flash relay. So if that is something that's a common occurrence, you can bring in current transformers and require light as well as increased current before you would let the relay trip. So that is something that can be used. Inside the relay itself, there is a backup circuit. So we have a regular microprocessor circuit as well as a solid state backup circuit. So there's a redundancy inside the hardware as well. Now, when we go to the tripping of the breaker, what if there is a break in the wiring from this connection point to the circuit breaker? So this relay, if you turn on the feature, will monitor these terminals for the presence of voltage to make sure that wiring is good and that the trip coil for the breaker is still operating as expected. Now, as an additional function, what if the circuit breaker you're trying to trip, what if that is damaged? Or what if the arc flash was in that compartment? The relay has the ability to check and make sure the circuit breaker has tripped. And if it has not, you can issue a second trip signal to a second circuit breaker. So we've really tried to build in a lot of backup safety functionality into the product. Now, I know there's a lot of words on this text, on this page, but the point I want to make here is, I mentioned that backup redundant circuit inside the relay, but there is a second benefit that provides. That backup circuit is solid state. So when you first power on the relay, the microprocessor circuit does take a little bit of time. So most relays will take maybe a half second, 2 seconds, 3 seconds. I don't mean just these relays, but all microprocessor-based relays will take some time to start up. But one of the times you might be most likely to have an arc flash is immediately on power up, because maybe you've been doing maintenance and you had everything turned off, which is great, did the maintenance, and you're going to turn the system on, but maybe somebody forgot the grounding or the earthing straps, and so there's a short on the bus, and you turn on the equipment, right into an arc flash. So if your arc flash relay is going to take 2 seconds or 1 second to start up, you could have an arc flash for 1 second, which could be devastating. Like that could be complete destruction of the equipment. So with these arc flash relays, with the Littelfuse relays, that redundant circuit is able to react extremely fast because it does not require a microprocessor to boot up. So we can have a trip signal if you're powering the product with a DC power supply. We can still issue a trip within 5 milliseconds right from a dead start. So that is also a very nice safety feature. Okay, so just a little bit on each type of relay. And, I could spend an hour talking about each one, but I just want to highlight 1 or 2 differentiators between each product. And then, of course, we'd be happy to talk in more detail if you have questions about each relay. So the PGR 8800, that's starting at the top of the chain. So this relay has the most functions available. And this one has input for 6 sensors. Now, if you have more than 6, you can use multiple PGR 8800 relays together, connect them together, and then it'll operate as one group. But this relay has the ability to do the current transformer inputs. So this is the only one in the series that does that. So you can use light plus current if you wish. This product has 1 high-speed trip. So this trip coil in the top right is a 1 millisecond response time. It's an IGBT. And so this provides the 1 millisecond trip. We do have 3 other contacts here that can give you up to 4 independent zones. So what I mean is you can decide which sensor will trip which output if you wish. So it depends how complex the system you'd like it to be. The AF500 is the next product in the series. And this product has 2 outputs, but they are both 1 millisecond high-speed trip outputs. And this model has 4 sensor inputs. Again, you can connect multiple units together with this digital I/O. But the other unique function about this product, other than the 2 high-speed trips, is the fact that you have Modbus TCP Ethernet communications if that's required. Now, if you have a little smaller panel where you do not require very many light sensors, maybe you only need 1 or 2 sensors, the AF100 is a great option. So it's a smaller package and it uses the same sensors, has the same redundant circuit inside. It's just a smaller package for the 2 sensors. And this model, these outputs are electromechanical. So the response time is about 5 milliseconds, which is still very quick. And the electromechanical contacts can carry a higher continuous current. So it depends on the type of circuit breaker you are trying to trip. Now I want to mention all 3 of these relays, the AF100, the AF500, the PGR 8800, they all have 2 power supplies. And this is again a redundancy feature. So you are able to have 1 power supply connected. You could have a low voltage DC or a line power 120/240, or you could have both of them connected at the same time. And if you connect both, the relay will operate. And if you ever lose one power supply, of course, the relay will stay powered from the other one, but it would give you an alarm. not a trip to shut down, but it would give you an alarm that you have lost one power supply. So that again gives you a redundancy capability. And a new one that's relatively recently been added is the AF25. And as you can see with the model numbers going down, this one is again reduced in size. So it was made to be very thin, so a very compact package. And this one has 2 sensors, and it removes some of the other functionality that may not be needed for a very simple application. So if there's a high volume panel application where you just need 1 sensor, maybe 2 in a small panel, but space is very, very tight, then the AF25 could be a very cost-effective way to add arc flash protection. So this information will be here for your reference. That shows a little bit of the differentiators between each product. But when we talk about how the sensors do their self-check, that internal redundant circuit, those are things that are across all of those products. So even though some have more or less features, we do not, we'll say, remove any of the really important critical safety functionality. One of the other interesting features on the PGR 8800 is the fact that it has a waveform capture. So if you're interested to see a chart or a plot of the light that's being measured, it will actually show you that for a selection of the last recent trip events. So this diagram on the screen, this is some testing I did in our Littelfuse Champaign, which is just south of Chicago. We have a high current laboratory, and we did some arc testing. So this 8800, you could see this green horizontal line was the trip level that was selected, which was 3 Klux. And when we issued the flash, you could see what the light sensor was measuring for light intensity. And so this is measured in Klux or kilolux, and that is the measure of light intensity. And that is what the arc flash relays are measuring. So these relays, one other function I'll mention about all of the Littelfuse relays, the AF100, 500, and 8800 have quite a flexible, adjustable light level. So based on how much ambient light you might have, you can adjust the sensitivity of these relays, whether you want them to be very sensitive or to be less sensitive. Now, don't worry, no matter what the setting is, you're never going to miss a real arc, because a typical arc flash would be measured in the hundreds of thousands or millions of lux. And here the maximum setting we allow is 25,000 lux. So I mentioned what happens if the circuit breaker is damaged and it doesn't trip. So that's why we offer the ability to detect that function and send a signal to an upstream breaker. So we do that by checking the auxiliary contact, or if you're using current with the 8800 relay, we can check and see if the current has gone away. So as was mentioned before, there is a lot of other documents and tools that talk about the arc flash relays, a brochure. This is an interactive page that I just took a screen capture of, but this is on the Littelfuse website where you can click on these points and it will share some information. But the relays are very easy to install, in the existing cabinets. So here we show a point sensor at the top, and then the fiber sensor in the back along the bus bar. And I'll show you some photos here in a minute. So as I mentioned before, sometimes I think a picture helps to describe it. Here we show two PGR 8800 relays connected together. So if you have equipment where you need many sensors, that is no problem. You can connect all the sensors you need, wire the relays together, and this relay here can trip the breaker even if it sees a flash on this side. And this all happens still within the 1 millisecond time frame. So if we have an arc over here on the left, seen by this relay, it's transmitted to this relay, and this will trip the breaker. This trip signal will still come in 1 millisecond or less. And in terms of the relay settings, there's a number of settings that can be made, and it's configured by plugging the USB into a computer. And the software does not need to be installed ahead of time. You simply plug it into the computer, it opens up like a USB drive, and you open the configuration tool. So it's very simple. There's nothing you have to install on the PC. So with the last little bit of time we have remaining, I want to show some pictures and talk about some of the applications. First, the AF25. So this is the ultra compact relay that I talked about. There's maybe small panels like this where any of the loose wiring, and this particular one is like a solar combiner box where you have all the strings from the solar panels coming in. There's a lot of wiring connections, and if you have loose wires, over time they can come loose and create an arc across the terminals. So with a tight space, you may only need one sensor and have a relay that you want to fit in a tight spot. So that is a good place where the AF25 could fit. Another common application is in some of the transformer compartments. So this in particular was a medium voltage utility transformer in South America. And here we see one of those point sensors installed at the top of the cabinet. And so it is very easily able to see for any arcs across those terminals on the top of the transformer. Now the fiber sensor, like I mentioned, is quite long. And one of the common ways to use it is to put it down beside the bus bar. So this would be able to see a fault anywhere down the line. So if you have a lineup of switchgear where your bus bar is 5 meters long or 8 meters long, this is an ideal spot to put the fiber. Another way that you can use the fiber is if you have a panel that has a lot of equipment, it's very dense, and there's a lot of locations where you want to be able to see an arc. So here on this breaker, there's terminals on the left side, and there's terminals on the right side. So you want to be able to see those. Now, a single sensor does not really have great line of sight to both sides, but here a fiber can come up and be looped around and come back up along these terminals and then up to the next cubicle. So in an MCC or somewhere where you have many small compartments, another option is to pull the fiber through those compartments. We just ask that the bending radius is about 5 centimeters on the fiber. If you pinch it too tightly, then light can escape. But our fiber it's very rugged, very robust for a fiber optic cable. And so it is very easy to work with, but we do ask for about that 5 centimeter bending radius. So another area where here in this piece of switchgear, they have all the bus work connected through some insulating points, but all the bus work in the back of the equipment. The fiber here, they just strung it along a structural member on the back so that it's able to see if there's any loose connection that forms that starts to generate an arc. So the fiber sensor is great at providing coverage for a long distance. And then in the control compartment, you have the arc flash relays here. So here's two PGR 8800s. And like I said, there's an alarm output as well, separate from the trip. So you can use that alarm output to put a light on the front of the door to say, is the arc flash system okay? Or does the arc flash system have an alarm? And so that would give you indication of whether it's healthy or not. This is another example of a point sensor here installed above a current transformer compartment in mining switchgear. So this is a underground mining substation that's very ruggedly built, and again, another good place for arc flash protection with the relay in the control cabinet. And this has been a common application where we have a lot of our mining customers across South America, North America, Australia, where they are using our arc flash relays, across their site. So this shows one more application where they have brought the fiber between compartments in the cabinet. And this one happens to be a water treatment facility. But here you can see where the fiber goes between compartments. Then you can do that with a rubber grommet to keep the fiber in place and not allow it to scrape on the metal.
Hey Mark, one question, man. If we have a big system like many compartments, how many PGR can work together in one system, and how many A0500? Just in one system, how many can work together?
That's a good question. With the PGR 8800, we can have 4 relays together. So that means we could have 24 sensors working together as one group. The AF500, there is no limit. You can continue to daisy chain as many relays as needed. So there's different ways to achieve that. I think with the PGR 8800, if you want to go above 25 sensors in one system, you could apply another set of 4, and there still are ways to connect those groups together, with some of the inputs and outputs. But that's something we could work through on the case by case. But I guess to answer the question directly,
the
AF500, there is no technical limit. You could connect as many of those together as you want. And the PGR 8800 is 4 that work together.
Yeah, I think it's understood perfectly. Hey,
Okay.
I take advantage of the time. If anyone have some question, please let us know, and we will answer right away. En español, si alguien tiene alguna pregunta, por favor no duden en aprovechar el momento en este momento y bueno, se responderá de inmediato. Mark Polo, que es la persona que si tienen cualquier tipo de pregunta, sea técnica o comercial, va a ser el indicado para respondérselo directo a lo que cada quien pueda requerir. Así que bueno, por favor, este es el momento, sea por el chat o que levanten la mano, les doy el permiso para que puedan conversar. Okay, go ahead, Mark. I just say to everybody that if you have any question, just ask for the chat or by chat or just by my microphone. So, well, just send them in.
Yes, perfect. I just skipped over the last 2 slides. One was just a summary of the relay, and the other one was just showing a sample of a few of our customers. We have a lot of customers around the world using these arc flash relays. So if there's questions, we'd be happy to, share a reference, where that's needed. But
Yeah.
Any questions, please drop them in the chat now, or contact the team here after. But I'm finished with my material here now. So any questions, please feel free to put them out.
Yeah. Thank you very much, Mark. Very nice presentation. I think I hope this is the first of many presentations together with the South America team, Latin America team. And well, thank you very much. It was a really nice presentation. Miguel, tienes el micrófono en mute. Si quieres alguna pregunta, por favor, simplemente desmuteate y podrás hacer la pregunta.
No, it's Mark. Miguel Abad from Peru is asking if there's drives features or applications on our product on Arc Flash.
They certainly can be used in the larger drive cabinets. We don't have anything. There's no specific product or anything different, about applying them to a drive cabinet. We have several applications where we've applied them into cabinets with drives, as well as some of the large utility sized energy storage, where you have container size power conversion. So similar to the large medium voltage drives, where there's a lot of energy happening there. And just because of different events that have happened in the field, some of those large energy conversion cabinets, they are now starting to use Arc Flash protection. So we've worked with a few installs across Europe and other places. So absolutely, they can be used in the larger drive cabinets. There's nothing different you have to do with the relay. Just need to make sure the light sensors are installed in a way that they can see the terminals where the arcing could occur that you want to monitor for.
Yeah. Speaking on medium voltage drive, we should monitor not only the control or the control panel, but also the transformer as well. Do we need to monitoring both? Is that right? Okay, thank you.
There is another question from Miguel Abad, Mark, and he asked, how can he test the AF0500, the 125? Then he said that their clients ask for a manufacturing certification about the testing. Is possible to have a report of test, or this product doesn't require it?
Well, that is a good question. So the way we normally test these products in the field in a cabinet is using a handheld camera flash. So not like the iPhone or a small camera are not powerful enough. But if you get a professional camera flash, that is what we would normally use to trigger the relay and confirm that it is operating correctly and can trip, the breaker device. So that's what we use for simple testing in the field. We do, of course, test the product in the factory, so we can provide a confirmation that the relay has, met all the factory testing before it's shipped. As far as the next level of detail, if the customer wants proof that the relay is reducing the energy, usually you would go into a electrical system software like ETAP or Easy Power, and in the software you can show what the reduction of energy is when you put the relay in. And as far as it's really, you can't do a real arc test on the equipment without it being slightly destructive, of course. So we have worked with some customers who have done type tests with our relays in a lab and have the verified test results. But for most customers, they are happy to use the camera flash, verify that the relay responds, the breaker trips, and that's typically what is done. Now,
Very
if there's
simple, actually.
yeah.
One install is very simple, the procedure.
Yeah.
Miguel, ¿se entendió la respuesta, Miguel? Vale. It seems that it was a good answer for Miguel. Anybody has any other question? ¿Alguien tiene alguna otra pregunta? Bueno, let's do by the end of the meeting, Mark. Nobody has any questions, as it seems. So thank you very much, Mark, and thank you very much to everybody. Oh, there is a question from Jena Shawar. Hey, Mark, is there any temperature limit for the environment in which the sensor can be placed, etc.? Like example, water application and high heat?
The sensors are designed for relatively high heat. So, we have, I think we certify in the product documentation a temperature of 70 degrees Celsius for ambient temperature for continuous operation. We have done temperature testing higher, so we know the sensors will work, up to 80 degrees, especially if it's temporary, not 80 degrees continuous, but they are certified for quite high temperatures. For the sensors themselves are like the fiber, if it gets wet, it's not going to cause a problem. But where the fiber connects to the transmitter and receiver, it is not waterproofed. So you would have to treat it just like any other regular electrical equipment. And for the point sensor is the same. Now, if you have an application where it is very wet, we have the ability to take the point sensor and make it and cover it with a full coating of conformal coating. So then it would be suitable to be used in a very wet location. So that is something we can do, but that would be a special order if it's a wet application.
Oh, but it's possible from factory to ask it this way.
For the point sensor, yes, that's correct.
Okay, perfect. There is another question from Orly Macias from Ecuador. How much is the range of cover of each sensor, of the point sensor and the fiber optics? How much area does it cover?
Sure. The point sensor and the fiber, we say it can see about 2 meters. So from where the sensor is, if you go out, so where the point sensor is installed in a half circle, you could see about 2 meters out in all directions. For the fiber, you could see out about 2 meters, again, in a radius around the fiber. And that's the range we give there.
Okay, perfect. Sé que se entendió, Orly. Son 2 metros de radio aproximadamente, claramente con la forma que tiene la cobertura de cada uno de los sensores. El sensor de fibra óptica cubre en los 360 grados de la fibra. En cambio, el sensor de punto tiene un rango de cobertura que es como un semicírculo encima del mismo sensor. Esto es del mismo, de 2 metros aproximadamente. ¿Alguna otra consulta? Any other question? Well, Mark, I think now we are over for today. thank you very much for your participation, man, and to be here with us with the Latin American market. It's really much appreciated, and we hope, like I said, that it's the first of many meeting together.
Excellent. Well, yeah, I appreciate the time and the questions as well. And anything else you think of later on, please pass them through, and the team will make sure we get them answered for you.
We will. Thank you very much, and thank you very much, everybody, for being here with us. Yeah, any question, please feel free to reach Vicky, and Vicky will answer all that you may need, from technical, commercial, anything, and quotes. Bueno, muchísimas gracias a todos por participar. Ya, si tienen alguna otra pregunta, aprovechen este momento, pero ya estamos cerrando. Y bueno, cualquier cosa, consulta que tengan, inquietud comercial, técnica, siéntense libres de contactar a Vicky. Vicky saben que siempre está ahí para atenderlos y los atenderá con la mayor amabilidad posible. Que tengan todos una feliz tarde y bueno, nada. Muchísimas gracias por estar aquí con nosotros.